What's shown here is the blood flow of an aorta during a pulse, during a heartbeat. And part A says find the magnitude of the acceleration for the speeding up phase of this. And part B says find the magnitude of the acceleration for the slowing down part. So on a velocity time graph, we know that the acceleration is the slope of the VT graph. So for part A, we would have something like A is delta V over delta T. Delta is the difference 2 moments. What 2 moments? Well, I'll start over here, which is at 0.20 seconds and 0 meters per second. And then we'll take our end is over here, which is a value of clearly 0.75 meters per second. And then we've got to be careful because, at least I misread the graph the first time, we have a third of the way between 20 and 40, so is that going to be like 26? So this is something like 0.27 seconds. And then 3, 4, yeah, so that's about right. Which is kind of goofy. That's a weird scale that they picked there, and it's a little bit annoying. But we end up, therefore, with 0.75 meters per second over 0.07 seconds. And we end up with 0.75. Something like 10.7 meters per second squared. But really, that becomes 11 because of our sig figs issues. We're going to do something similar on this one. We're going to take the slope of our VT graph, but now our initial moment is the part we just had, and our final moment is going to be the end of the downward phase. And so if we look, our initial moment now is at 0.27 seconds, and we said it was 0.75 meters per second. And then our ending place is at 0 meters per second, but it happens at 0.40 seconds. So we end up with minus 0.75 meters per second over 0.13 seconds, or we get something like minus 5.769 meters per second squared, which becomes minus, when we round it to our 2 digits, minus 5.8 meters per second squared. Now, interestingly enough, the textbook does not give that as their answer. They give 5.6 meters per second square, and I know why they do that, because they use the time here, and they call that 267 seconds. They take a third digit. And the argument there might be that we have 2 digits of accuracy, but you should always keep an extra digit when you do the division. Yeah, that's when we get obsessed with sig figs over reasons that we shouldn't. So it should be something like around minus 5.8. In either case, the actual answer, of course, would be plus 5.8 meters per second square, because they wanted the magnitude, so we take the absolute value.